Alright, this video is a continuation of the video where we're doing examples, and so we were left with question D, where we want to find the angle and the point of intersection. We're going to start with the angle. For both of them we need either the vector form of the equation of each line or the parametric. Symmetric is not very helpful for these, as you'll see. So I'm just going to write, so this is these are the parametric equations for L1 9 plus 5t, and then 13 plus 5t, 13 plus 5t. So the important thing from these are the coefficients of the t, which give us the direction vector. So for L1 it's 1 5 5. Then we're going to do the same thing for L2. Now you're going to notice, as we already worked through this before, we are going to set this to be equal to a different parameter. Then x is 7 plus 2 lambda, so this is L2 7 plus 2 lambda. Y is 2 plus lambda, and then z is negative it's negative 6 minus 3 lambda. 6 negative 6 minus 3 lambda, which means M2 is 2 1 negative 3. So for the angle of intersection, angle between the lines, because the lines may not intersect anyway if they are skew, but they're still going to make an angle. We use the product, the dot product. So M1 dot M2 is the magnitude of M1 times the magnitude of M2 times the cosine of theta. So for M1 dot M2, it's going to be 1 times 2 plus 5 times 1. So that's 1 plus 5. The last one is 5 times minus 3, which is minus 15. The magnitude of M1 is 5 squared plus 5 squared plus 1, so that's square root 51. The magnitude of M2 is 2 squared plus 1, so that's 5 plus 9, square root 14 cosine theta. This works out to negative 8, so that means theta is going to be inverse cosine negative 8 divided by square root 51 times square root 14. In degrees it's going to be 107. As we mentioned before, if this is negative, then the angle is going to be obtuse. So that's going to be the angle between those two lines. Point of intersection. Okay, so in principle it's going to be similar to finding the intersection between two lines in 2D. However, this time we are going to have 3 equations to equate. So at the point of intersection, x must be equal to x, y must be equal to y, z must be equal to z. So first of all, so this is a point of intersection. 3 plus t must be equal to 7 plus 2 lambda. Then 9 plus 5t must be equal to 2 plus lambda. So 9 plus 5t must be equal to 2 plus lambda. Then lastly, 13 plus 5t must be equal to negative 6 minus 3 lambda. 13 plus 5t minus 6 minus 3 lambda. Now, as you can see, we have got a system which is, I think the term is overdetermined. It's got 2 unknowns, but we've got 3 equations. So what we do is we choose any 2 equations and solve, and then if there is a point of intersection, whatever numbers we find must also agree with the third equation. So here, for instance, we are going to take this as equation 1, take this as equation 2, and solve. If we multiply the second equation by 2, so we're going to have 3 plus t equals 7 plus 2 lambda. It's going to be 18, it's going to be 10t multiplied by 2, and then we're now going to subtract. 18 minus 3 is 15. Or maybe let's just do this here. So it's going to be 15 plus 9t. 4 minus 7 is minus 3, and that's going to be 0. So 9t is going to be negative 18. So t is negative 2. And then we can find lambda by plugging into, say, this one. So t is negative 2. So that's 9 minus 10. And 9 minus 10 is equal to 2 plus lambda. So lambda is going to be minus 3. Okay. If we've got a point of intersection, these two must satisfy equation number 3. Okay. So if we plug in t is negative 2 this side, it's going to be 13 minus 10, which is 3. If we plug in lambda is negative 3 this side, it's going to be minus 6 plus 9, which is 3. And so we do have a point of intersection, so the two lines are not skew. If the third equation is not satisfied, then you conclude that the two lines are skew. Then after that, the point of intersection is simply a matter of plugging into any of these. For instance, we had t is negative 2, so that's going to be 3 minus 2. It's going to be 9 minus 10, which is negative 1. It's going to be 13 minus 10, which is 3. So that is going to be the point of intersection. Okay, so that is that. Let's go to a second example. Right, in this second example, we are given pairs of lines. So for each pair of straight lines, we need to determine whether they are parallel, intersect, or are they askew. If they are parallel or skew, we want to find the distance, shortest distance between the lines. If they intersect, we need to find the point of intersection. So there's L1 and L2 for A, L1 and L2 for B. So let's get on with A. So for the whether they are parallel, we need to inspect the M1 and M2. We've got 1, 2, 3. 1, 2, 3. Then for the second line, we have got 2, minus 1, minus 1. Minus 1, minus 1. Okay, if you want to be systematic about this, you can just make, like, you can see that the first entry here is 1. If you factor out 2 here, then you're going to have 1, negative 1/2, negative 1/2, and so clearly that is not a constant multiple of M1. So M2 is not equal to K times M1. This implies that L1 and L2 are not parallel. Okay, so if they're not parallel, they may intersect, they may not intersect. So we need to write the two equations in parametric form and then solve the system. For L1, x is going to be 5 plus lambda. For L2, x is going to be 2 plus mu. So 5 plus lambda equals to 2 plus mu. And then y is negative 4 plus 2 lambda. Negative 4 plus 2 lambda. For L2 it's going to be 0 minus 2 lambda, minus 2 mu. So it's just going to be minus 2 mu. And then for Z it's minus 2 minus plus 3 lambda. Minus 2 plus 3 lambda. And for L2 it's 1 minus mu. 1 minus mu. One moment. Okay, if we solve between 1 and 3, we can just add, and mu is going to cancel out. So 1 plus 3 is going to give us 3 plus 4 lambda is equals to 3. So this is telling us that lambda is 0. If lambda is 0, if we plug in 0 here, then mu is going to be 3. Mu is going to be 3. Now let's see if that satisfies equation number 2. So if we plug in lambda is 0 on the left hand side, we get negative 4. plug in new is 3 on the right hand side, we get -12. These are not equal, so we have got to conclude that L1 and L2, so even though they are not parallel, they don't intersect, so those two lines are skew. Then to find the distance between the two, we have got to use the formula. This is the formula R2 minus R1 dot M2 cross M1, all divided by the magnitude of M2 cross M1. I can just say that R2 minus R1 is going to be 3 minus 4 minus 3. Let's see how that works out. So we are subtracting, so R2 is this one, R1 is this one. Okay, so that's going to be 2 minus 5, which is minus 3, 4, 3. So minus 3, 4, 3. So that's R1 minus 2. And if we do M2 cross M1, just confirm this for us, we're going to find minus 1, minus 7, 5. And then if we take this thing and plug them into this formula, we do find rho to be 2 over root 3. Okay, so that sorts out question A. Question B, so there we've got B is this one. There got M1 there, but we are going to have to work on this one and write it in parametric form. So if we just do this, okay, so M1 this time is the vector 3, 5 minus 2. And then if we equate this to say t, then x, so this is for L2, x is going to be minus 4 minus 6t, y is going to be minus 5 minus 10t, z is going to be 8 plus 4t. Which means M2 going to be minus 6 minus 10, 4. So if we factor out for M2, if we factor out -2, okay, then that's going to be 3, that's going to be 5, it's going to be -2, which is exactly the same as M1. So it's going to be -2 times M1. Then we can conclude that L1 is parallel to L2. And then to find the distance between the two of them, we simply use this formula that was presented in that in that theorem. R2 minus R1 all divided by M. So here it's up to us which M we use, but once we choose one M, so for instance if we use this M, then we must use it right through. Yeah, so if we use that M, then M cross R2 minus R1 is going to be, so we're using this M. Which M are we using? 3, 5 minus 2. So we're going to plug in 3, 5 minus 2 here. Then R2 minus R1. So it's going to be, if we do minus 4 minus 5, that gives us minus 9. Then next, minus 5 minus 4, that's minus 9 again. Then last we are going to do minus 8, take away negative 2, so it's going to be 10. Okay, if we do this calculation, I'm going to get 32 minus 12 and 18. Okay, so that slots into the numerator. Denominator is just going to be magnitude of this vector, and then we find that rho is going to be 2 square root 373 all divided by the square root of 38, which is simply the square root of M here. And so that's going to be the distance between those two parallel lines. The last section for this segment is going to be planes in 3D, which is going to be in the next video.